Hello friends, now we're going to solve a right triangle application problem which deals with two angles of elevation. So here's our problem. The Golden Gate Bridge has two main towers of equal height that support two main cables. A visitor on a tour boat passing through the San Francisco Bay looks up and views the top of one of the towers, and he estimates the angle of elevation from the horizontal to be 30 degrees. So he's still on that tour boat and he can measure the distance he's traveled. So after sailing 670 feet closer, he again looks at that exact same tower, and now that he's closer, he has to look up a little higher. So he measures a new angle of elevation from the horizontal to be 50 degrees. Let's approximate the height of the tower to the nearest foot. So let's think about what we have here. We have a guy sailing on a boat in the water, and he's looking at the red Golden Gate Bridge. So we'll say he's over here at point A. And initially, he looks up and measures that angle of elevation to the top of that tower to be 30 degrees. So our touristing math aficionado travels, and he can measure this distance, 670 feet. So he's moved along this line. We'll say now we're at point B. Now that we're closer, we have to look up a little higher. So this angle of elevation is a little bigger. We estimate that it's 50 degrees. We need to know the height, I'll call this H, of the tower. We want to approximate the height of the tower. So we have two right triangles here. I have a smaller right triangle, and then I have a larger right triangle. Now let's look at our picture and our information that we stated. Make sure we got all of these pieces drawn on our picture. So we've got my 30 degrees, my 50 degrees. What I didn't draw on my picture was that 670 feet. So that's the distance from A to B, which is 670. All right, so let's think about this. I'm going to extrapolate, pull two different right triangles out of my picture. So the first right triangle will be this smaller one with a 50-degree angle. Got this guy here. I know this 50-degree angle. Now I've got this H that I'm searching for. I don't know either of the two sides. My other right triangle that I'm going to pull out is the larger one, containing that 30-degree angle. And again, that vertical side, that's going to be my H. So I'm going to have to create another variable because I don't have enough information. So what I'm going to do is I'm going to let the base of my 50-degree right triangle measure X. So if this, from this vertex to B, if that measures X, then this entire blue length is going to measure X plus 670, which is the entire base of this brown triangle. So I'm going to write 670 plus X. So now I have two triangles. Each triangle has the same two variables, X and H. If we have two variables, we need to develop two equations. We'll be solving a system of equations. So I'm going to look at solving each of these right triangles or setting it up for X and H. So with angle 50, I have an opposite and adjacent side. And by SOHCAHTOA, that lets me know I'm going to write tangent of 50 is opposite H over X. Similarly, my 30-degree triangle, I know an opposite and an adjacent side. Those are what are being considered. So we could write tangent of 30 is opposite H over adjacent 670 plus X. Now you can see we've created two equations with two variables. So what I need to do is I need to isolate one variable in one equation, and then I can sub it into the other. So for my purple equation, I'm going to rewrite that and say, well, that's h equals x tangent 50. So if I know that h is equal to x tangent 50, I can plug it into my other equation. So this would give me, I have tangent 30 equals x tangent 50 over 670 plus x. So now, using substitution, I've created one equation with one variable. We need to solve for that missing variable x. So in order for us to do this, I'm going to treat this one equation like a proportion. That tangent 30 is over an invisible 1, and now I can cross multiply. Cross multiplication is going to give me 670 plus x times tangent 30 equals, I would have 1, which I don't need to write, times x tangent 50. Solving for x, I'm going to distribute that tangent 30. So I have 670 times tangent 30 plus x times tangent 30 equals x tangent 50. I'm going to collect this x term to the other side of the equation. So I've got 670 tangent 30 equals x tangent 50 minus that x tangent 30. Now I have an x in front of both of these. I can factor that out. 670 tangent 30 equals x times tangent 50 minus tangent 30. Tangent 50 minus tangent 30, that's a number. I can type that number into my calculator and get an approximate decimal value. I'm not going to do that yet. Since that's a number times x, I'm going to divide it, and I have 670 tangent 30 divided by the quantity tangent 50 minus tangent 30 equals x. So that's the value I need to determine. You need to be able to type this into your calculator in degree mode and get that x is approximately 629.5941. So that represents x. Again, I'm going to encourage you, if you haven't, pause right now and make sure you can type that in your calculator and get that output correctly. One thing that's really important is to make sure that that entire denominator is grouped. You also want to make sure that you're in degree mode. Remember, you can push the mode button and change between degree and radian mode in your calculator. So once you've got that, you're thinking, yay, I'm done. I found x. Is x really what we wanted to find? So let's go back up and look at our picture. We know x. What are we interested in finding? We want to approximate the height of the tower to the nearest foot. So we know x. We want h. If we go back down a little bit into our work, did we define h in terms of x? We did. We said that h is going to be equal to x tangent 50. So we know that h equals x tangent 50. Now, You want to be careful using your calculator. You could use the answer button and say answer, previous answer times x tangent 50, or you could type it in here exactly, which is the way I'm going to write that. We have this entire x value, 670 tangent 30 divided by tangent 50 minus tangent 30 times tangent 50. So however you want to type it, you need to be able to determine, however, that the answer for H is 750.320978. If you're using an exact value as opposed to this proximate, use that exact value, or you use the answer button, which is going to pull in that exact value, you're going to get this many decimal places. So H is roughly 750 feet. The height of that tower is 750 feet. As always, email me if you have any questions.